Now let's talk about part B. How are we going to actually evaluate what this is? So how are we going to find the exact area under this curve? And here's how we're going to have to start. I'm going to copy this over because we don't have enough room here. So for example 5, we said that our expression was sigma 4 over n, and then we have 1 plus 4k over n quantity squared plus 3. Okay, so this is our expression now. K goes from 1 to n, and this is example 5, right? So this is 5b. Okay, so I want to figure out what exactly happens with this. What we know is that in order for us to use our sigma formulas, we need to have a string of terms, so we can write these out. So I'm going to first square what I need to square. So k goes from 1 to n. We're going to have 4 over n. You should know how to square a binomial. You know that this is going to be 1 plus twice the product there. So 8k over n plus this last term squared, 16k squared over n squared. And then we're going to have plus 3. I'll clean it up a little bit. K goes from 1 to n. We have 4 over n. And inside this, we're going to have 4 plus 8k over n plus 16k squared over n squared. Okay, so multiply. So square this. So square what you need to square first. Then clean it up a little bit. I like to distribute. So that will give us sigma. K goes from 1 to n. And we're just going to have 16 over n plus, again, distribute 32k over n squared plus 64k squared over n cubed. Now, here's what we can do. Now we can split this up. Properties of sigma. We have k goes from 1 to n of 16 over n plus k goes from 1 to n of 32 n squared k plus sigma. K goes from 1 to n, 64 k squared over n cubed. Now, if you remember, the only variable we have is k. So for this very first term, we can use that constant property. So we know this is going to be 16 over n times n. In our next term, I'm going to pull along the 32 over n squared. And the formula for sigma k is n plus 1 over 2. And then I'm going to pull along the 64n to the third. The formula for k squared is n plus 1, 2n plus 1, all over 6. And now you're going to do something a little bit different. You really just want a string of terms. So I'm going to simplify where I can. For the first term, the n's cancel out, and we're left with 16. For the second term, I can cancel out a single n, and we're left with, I'll distribute that 32. 32n plus 32 all over 2n. For the last set of fractions, I can again cancel an n. That's going to give us n squared. I might as well cancel 6 into 64. I'd like to have smaller numbers, 3 and 32. And now I know I'm going to have 32 times. I'll FOIL this out, 2n squared plus 3n plus 1. The whole thing is over 3n squared, and I'm going to break this up as much as I can. 32n over 2n plus 32 over 2n. I can do that because I have a single term on the bottom. Same thing over here. When I distribute on the top, I'm going to have 64n squared, but that's going to be over 3n squared. My next term, 32 times 3 is 96n over 3n squared. My last term is going to be plus 32 over 3n squared. And now I'm not going to worry about the algebra, because way back in the beginning, in order for us to get an exact area, here's what has to happen. So I drew a bunch of rectangles. I would have gotten a better approximation if my rectangles were closer together. I think I'm on the wrong one. So here's what would have to happen. If I drew rectangles that were infinitely skinny, notice the amount of jutting out wouldn't be as great. So in order for me to get the best area that I possibly can, I need to have as many rectangles as I possibly can. So way back at the beginning, we know that what we're ultimately looking for is the limit as n approaches infinity. So all of these are just waiting for me to take the limit as n approaches infinity. And I'm going to make sure that I copy this because that, in fact, is proper math notation. So I'm taking the limit as n approaches infinity of this whole thing, the limit as n approaches infinity of this whole thing. And now that I'm up to this part, the limit as n approaches infinity of this whole thing, well, here's what I know. 16 is not affected by what's going on with n, so that's just 16. For my next term, the n's cancel out. So that will just give me 32 over 2. That's 16. For the next term, though, I have 32 over 2n. And as n approaches infinity, the bottom is going to be out of control. It'll dwarf the top, so this eventually is going to be 0. For this term, my n squares will cancel out, and this gives me 64 thirds. For this term, the n on the bottom outweighs that on the top, so that will be equal to 0 eventually, or get pretty darn close. And for the last term, again, I have an n in the denominator, so as n approaches infinity, that will also approach 0. So all I'm left with is, let's see, 32, which I'm going to think of as 96 thirds, plus 64 thirds, is going to leave me with a total area under the curve of 150 thirds. I hope that's right. 160 thirds, which in fact is not divisible by 3. That's my exact area under the curve.